Hello, welcome to another video of thermodynamics. In this video, we're going to look at the basic concepts of thermodynamics. First, for any physical system, any problem in thermodynamics, it is important to define your system. In thermodynamics, system is defined as any quantity or matter or region in space chosen for study. So it is a quantity of matter or region defined to or chosen for your study. For example, if you consider a piston cylinder device and heat is supplied to it and you're going to take some work out of it, in that case your system is defined by these boundaries, which is called your system boundary, and that's your system. And any physical system is separated by its surroundings with a boundary. The system is separated with a boundary that's called system boundary. And systems in thermodynamics can be categorized into two broad categories. One is closed systems, the other one is open systems. In closed systems, the mass cannot enter or leave the system. So at any given time, the mass inside a closed system is a constant. There's no mass going in and out of the system. But the system can interact with the surroundings through heat and work. The system can take energy through heat or work. The system can uh, give energy to surroundings through work or heat, or release energy to surroundings. And the other category is open systems. In open systems, uh, the region of the region is constant, right? If you can see that region is constant, or the volume is constant, but the mass can interact with the system as well as the heat and work. Now, in Thermo 1, you talked about nozzles. So nozzle is can be defined as an open system. The open system may consist of real boundaries and also imaginary boundaries. Usually imaginary boundaries covers the places where the mass can enter or leave the system. And in the analysis of control volumes or open systems, we take a different approach than what we used in closed system analysis. Now, system boundaries can can be fixed or moving. Now, in this closed system, you can see that piston can go up and down. That means this boundary at the top can move or can change, but it still is the closed system. And here there are fixed boundaries around these edges of the cylinder, as well as in this case, right? You have one moving boundary and one and three, two or three fixed boundaries, and also we have an imaginary boundary here, right, where we can interact with mass. One of the special kind of system is known as an isolated system, which is a special kind of closed system. In a closed system, even though the mass cannot interact with the surroundings and the system, with the closed system, the heat and work can interact. But in isolated system is something that is completely isolated, where heat or work cannot interact with the system and surroundings. So this is the basic uh, concepts of of systems and categories of systems, and that will be useful for you to understand all the other concepts in thermodynamics. Once we identify a system, then we need to define system. To define system, we need to define characteristics of the system. Now, as explained in the introductions video, we're going to take the macroscopic approach for thermodynamic systems or classical thermodynamics. When it comes to macroscopic analysis, we need macroscopic properties or macroscopic characteristics of the system. These are called properties. And the properties can be widely categorized into two groups. One is intensive properties and the extensive properties. Now, properties that are not depend on the size of the system or the extent of the system are called independent intensive properties. So, for example, temperature is an intensive property, pressure is an intensive property, right? And there are several other specific properties that are independent of the mass of the system or the extent of the system, which we're going to encounter in the next videos or the classes. And extensive properties are the properties that depend on the mass or extent of the system. Energy is such a property, and we have talked about enthalpy is another property that depends on the extent of the system, extensive properties. So properties are macroscopic characteristics of the system, and the systems can be properly defined by the properties. A state. Now, once you know the state, now we identify what the system is, then we have the properties, right? And then the state. State is a condition of a system that can be completely described by its properties. Now we have a system. Let's say, for example, the system is a can of Coke on this table. So that system can be defined by its temperature, and the pressure of that system is under, right? So the pressure of the system is the pressure can be treated as a pressurized can, a little bit higher than the atmospheric pressure, or is the same as the atmospheric pressure. Or we have a temperature is 40 degree Fahrenheit. That defines the state or the condition of the system. Okay. And how many properties do we require to define a state or identify or define that condition? For a simple compressible system, we only need two independent intensive properties. We need two independent intensive properties. So what is a simple compressible system? We're going to talk only about simple compressible system during throughout this course. Simple compressible system is a system that is uh, not under the electrical or magnetic gravitational motion and surface tension effects. And then once you define system, and then processes identify system, and then you define the properties, and then we come into the state, and then we have the processes. Now what is the process? Now we define system, and then state, one state, temperature is T1, pressure is P1. Now after some time, this system changes its temperature or pressure, or either one of them. Let's say one of them, state 1, and this denoted by state 2. Now for example, that Coke can, if you leave it for a significant amount of time on the table, it will eventually comes to the temperature of the room. So then what happened was one of its properties were changed. Okay, properties were changed. So once the property is changed, that means the state is changed. Now how do we define this change? This change in states, one equilibrium state to another equilibrium state, is called the process. Now we learn different type of processes. Isobaric process. An isobaric process is a process where pressure is constant, right? For example, we have a unrestricted or frictionless spring piston cylinder device. So this piston is free to move under the pressure of atmosphere. So this inside this pressure P1, stays the same during that motion. An isochoric process, where the system has a constant volume. For example, it's a rigid tank, right? You have a rigid tank. For example, if you have the closed container with Coke, right? Its volume is always constant, even though its temperature change. The volume does not change significantly. So that's called isochoric process. And isothermal process, some processes are there where the temperature does not change at all. Adiabatic process. Adiabatic process is the process where there's no heat transfer take place. Polytropic process. Polytropic process is a process where P V to the power n, n could be any number, 1, 2, 3. This relationship stays as a constant. And we learn isentropic process, where entropy constant during the process. Now we learn about systems. Then we learn about properties. Properties are required to define a system and define a state. And then we learn about states and changing transformation of states. That's called processes. And then what if you need transform these processes from transform this state from one state to another and come and to another and come back to the initial state, right? So we call it a thermodynamic cycle. Thermodynamic cycle is uh, a sequence of processes that starts and ends at the same state. Take this fossil-fired power plant schematic as an example. Now, in this cycle, water is the working fluid. The water first comes into let's consider first comes into this steam generator. In the steam generator, what would happen is it's a change of state of that water system, right? Water in the steam generator, the temperature of the water is increased and steam is generated. There's a phase change process as well. That's a one process. So process one here. This is system one, and the steam state is transferred from state 1 to state 2. Let's say this is state 1 here and transfer to state 2. And then you have an expansion process in the turbine. That's called process 2 to 3, expansion process. And then we have heat rejection process. So this is a heat input process, right? Heat absorbing process, right? And this is heat rejection, right? Heat rejection process at the condenser 3 to 4. And then there's another process here. The pump is missing in here. So you have a pump and bring back to the same pressure and at the state 1. So then that's a compression process, right? So how many processes we have? We have 1 to 2 process, 2 to 3 process, 3 to 4 process, and 4 to 1 process. It started at state 1, went to state 2, went to state 3, come back to 4, and 4 to 1. So that's a sequence of processes: heat addition, expansion, heat rejection, and compression. Heat addition, expansion, heat rejection, and compression. That's a cycle. That's called a thermodynamic cycle. So this type of power plants can be analyzed by analyzing the thermodynamic cycles. And then a little bit of concepts regarding some properties that we're going to meet, that we're going to see frequently. One is pressure. Pressure can be measured using a pressure gauge. That's you measure the gauge pressure. And to use the absolute pressure, you need to add that gauge pressure to the atmospheric pressure. Atmospheric pressure can be measured using a barometer. And You already learned about how the pressure varies with the depth. Let's say this is a quiescent water tank, and you have a pressure, atmospheric pressure at the top, right here, and with the depth, you have if the density of water is rho and the gravitational acceleration is g, you have that rho g h change, rho g h pressure change. So you need to add that into the atmospheric pressure to get the pressure at this point. Let's say this height is h. Height is h, you have rho and g, density and gravitational acceleration, and then you can find the pressure at here, p, and here that's equal to PATM plus rho GH. Okay. And then some other properties like density, you have density rho, that's equal to volume divided by mass, and you have a temperature, another property, and you know about the enthalpy, that's another property, that's actually internal energy plus uh, PV, right? And internal energy also another property, and you have kinetic energy, potential energy. These are the things that you talked about in Thermo 1. And all these concepts of thermodynamics are built on four basic laws: zeroth law, first law, second law, and third law. Zeroth law deals with the temperature, first law deals with energy, second law deals with entropy, and this is the deal with absolute entropy. And all of these laws are succinctly and very nicely, taking the statistical considerations as well, are described in this small booklet. If you have time and if you are interested in the subject, I highly recommend to read uh, this little book, which is written by Peter Atkins, one of the leading authors in thermodynamics. Uh, this is not expensive book. This is maybe like you can buy it from Amazon for less than $10. Um, you can read this book. This is very nicely and succinctly described what the relationship between these four different laws into different properties and how it is connected to the statistical explanation of the thermodynamics. Well, with that, I would like to conclude this video. Uh, Please take your time to watch and think about the concepts, and these concepts are going to be used over and over again in next few weeks of this class. Thank you very much.